Hi, this is Marco with Global Specialties. Today I have the R700 Vector robotic arm, as you can see here. And I want to just show you an application. I want to demonstrate to you that the R700 is perfect for teaching physical science, physics, even chemistry. So I'm going to use the R700 today to demonstrate a physics lesson on air pressure. So let's talk about air pressure. Have you ever swam underwater? Then you'll understand pressure a little bit. When you're underwater, you know that the deeper you go, the more your ears hurt, right? Because you're under a bunch of water. You're like under the ocean or under your swimming pool, and there's pressure, that water pressure pushing into your ears. It's pushing on you in every direction. And actually, the deeper you go in the water, the more the water pressure. So the pressure is stronger down below than up above, but it's all around you. And outside of the water, when we're on the land, we're also experiencing pressure, but air pressure. We're actually living under an ocean of air. It's all around us. Air pressure is pushing on us all around. And it depends on how deep in the ocean of air you are, how great is the pressure. So at sea level, the air pressure is 14.7 pounds per square inch. 14.7 pounds per square inch is quite a bit. Look at your thumb, that's about a square inch. And if you push on an aluminum can with about 15 pounds of pressure, it's very easy to see that the can is going to start being crushed. So if air is pushing in on a can, normally with around 15 pounds per square inch of pressure, why are cans up and open and not smashed all the time? The answer is because there's air inside the can pushing out on the walls of the can, which keeps it open, keeps the integrity of the walls. However, what if you take the air out of the can? Here we have an aluminum can, and what we're going to do in this experiment is we're going to put a little bit of water in the can. So what do we have? We have water in this can, and then we have air molecules floating around in here. But if we heat up the water, put fire under the can, we heat up the water will boil and start to turn into steam, water vapor, inside the can. And when it does that, it will push the air out. It will push the air out. You can't see that because it's just air, but it will push the air out. And then inside the can, you will no longer have air, but you will have water vapor in the can and still a little bit of water. So when you start to see steam coming out of the can, that means the air has left already, and what remains is water vapor. Then if we touch this aluminum can to something cold, like a bowl of cold water, instantly these vapor molecules, or water vapor, will condense back into cold water very quickly. And if the lid happened to be sealed off at that moment, the same moment that we make it cold, we seal off the lid, this water vapor condenses back into regular water. But what is here? What is inside the can? It's what we call a vacuum, or nothing, or space, emptiness. There won't be anything in the can. There will no longer be air pressure inside the can matching the air pressure outside the can, and so, which is normally the case, and the can can stay, open or up with its integrity, okay? But here, when we take away the air pressure inside, all of a sudden, this 14.7 pounds per square inch can smash the can, imploding the can. And that's what we want to see the Vector robotic arm do. So let's try it. First, I'm using a laptop to control the robotic arm, and I have the robot arm here, the Vector, a bowl of cold water, or room temperature. It's not important that it's very cold. An aluminum can, just attached to tongs, and it's just a basic aluminum can, and it's empty, just a tiny bit of water in there, just about a teaspoon of water. So I'll put my safety glasses on, and we'll light up the Bunsen burner, or my camping stove. And here we go. And now the robotic arm has placed the aluminum can over the fire, and we have to wait for the steam to start coming out of the can. When we see steam coming out, you can also hear a popping sound. You'll know that the air has been pushed out, and all that is left in the can is the water vapor. Then it is ready to touch the cold water, whereupon the water vapor will condense immediately back into cold water, leaving a vacuum in the can. So see if you can hear that popping sound or see the vapor coming out of the can. It's a little hard to see, but you should be able to see some. When you're doing this live, you'll see water vapor coming out, and you'll hear the popping sound. The popping sound is really the distinctive or the telltale moment. Can you hear that popping sound now? And you can see vapor, so here we go. Keep your eye on the can. How's that? Pretty cool, huh? Pretty well smashed, don't you think?